So in 2016, College Board added L'Hopital's rule to AB required material. I've always done it because I actually didn't know it wasn't on AB prior to 2016, so I've always taught it, but it got added, and last year they even changed how they grade it. So I have to be really clear with how you're expected to execute L'Hopital's rule, but first I'll tell you what it is, and I'll tell you what it's used for. It goes all the way back to our first topic. We have the 3 pillars of calculus. What was the very first one? Limits. It's a limit deal. But in order to execute it, you need to know how to take derivatives, which is why it's not taught in chapter 1 with limits. Like even one we do today, we have to know the derivative of ln u. And back in chapter 1, we didn't even know what a derivative was, let alone natural logs derivative. So we had to get this far before I could talk about L'Hopital's rule. So I'll just tell you what it states, and I'm going to sort of abbreviate it so we're not writing a big paragraph. But it says if you're taking the limit as x approaches c of a quotient of functions. So I'm just going to write g of x over f of x. And if you get one of two things, so I'm going to branch off here. Technically, you're supposed to show them going there separately, but I don't want to rewrite. If the top ends up being 0 and the bottom ends up being 0, you might say, how do you know how to do that? You only know how to do a specific kind. The kind where you factor, then cancel, and then replug, or sometimes the conjugate method we used, but we kind of already know that 0 over 0 is called an indeterminate form and it needs more work. So let's go down to one that can be done just before I even finish without L'Hopital's rule. If I didn't teach you anything for this one, how would we launch into finding its limit? We'd say, oh, I can see that although both of these plugging in a 2 is giving me a 0, I don't say the limit doesn't exist. I factor the bottom. I cancel. Correct? I create a function that's identical to the original everywhere except at 2. So graphically, it kind of helps to revisit all this stuff since we're getting closer to an AP test and it's been months and months since we've done limits. What that means is this function right here and my function 1 over x plus 2 are exactly the same. 1 over x plus 2 is the parent function 1 over x that's been moved 2 to the left. Its asymptote is moved over. It looks like this. So you don't have to draw this in your notes. I just want to kind of show you what we're doing. We're approaching 2 from both directions. So I'm coming in at 2 from both directions, and the fact that these cancels means what is actually on my graph? A hole in the graph, but I'm still there. So a hole disrupts continuity, but a limit still exists there. So, and if you were to graph it on your graphing calculator, you wouldn't see that hole there unless you really zoom in on it. And then you'll see, oh, then you'll see the issue that's going on there. So then we replug the 2 in and we arrive at 1/4. This is the location of the discontinuity. That 1/4 is the limit of the function. L'Hopital's rule allows us to get the very same answer doing something very different. For this one, I'd say it could go either way. This one, and I haven't even told you L'Hopital's rule yet. I'm waiting. I'm doing 2 of them that don't require it. Do you guys remember when we approach infinity, how we found the limit? Do you remember? Yeah, we look at those powers and we say, who's in control? There's actually a more analytic way to do it, but the end result is the same. So like if you were to read in a textbook, it says to divide every term by the highest degree of the denominator. But when you do that, as I go to infinity, this goes to 0. As I go to infinity, this goes to 0. As I go to infinity, this goes to 3. So it basically does the same thing as me telling you all non-highest powers aren't in control of the end behavior. So we just take them out. Really, the negative 5x squared is controlling the top function, and the 3x squared is controlling the bottom. They are tied, so we steal the coefficient. So we just say, all right, limit x approaches infinity of that guy. I'm going to call this h of x, just because I don't want to rewrite it. H of x, you're right, Golden, it's negative 5/3. That's how I would still do this kind. So I'm going to repeat. I'm going to teach you another way to do limits. You get a choice for this kind. You might still want to factor cancel, just kind of naturally falls out. This kind with the polynomial over the polynomial when you approach infinity, I'd still do it this way. All right, but before I give you L'Hopital's rule, this one you can't do any other way except L'Hopital's. So when I plug a 0 into this, I get cosine 0, which is 1 minus, I get a 0 on the top, a 0 on the bottom. I am completely stuck on this one until I tell you, right? Can't factor it. I can't multiply by a conjugate and get things to cancel. I have no clue. So that's where the conclusion of this comes in. So L'Hopital's rule says, if we're approaching and we get 0 over 0, or we get another one of the 7 indeterminate forms in math, which is infinity over infinity. There's actually 7 of them. We only deal with 2. We only hit the surface of L'Hopital's in here. You'll get it in depth in Calc 2. We spend a good 2-3 days on them, and we do all 7 indeterminate forms, and it gets actually pretty rigorous, but for us it's really easy because we just have to skim the surface for Calc 1. It says, as long as you get one of these two, keep in mind these are ratios, like 0 over 0 and negative infinity, maybe over positive infinity. We have no clue what those are. Wouldn't you agree? What L'Hopital's rule says is you can take the limit as x approaches infinity of their derivatives. And there's a proof for this in our book. I think it's in the back of our book. It's not super hard to understand. Has stuff you know in it, but it's pretty complicated. Has mean value theorem in it. Anyway, it says if you take the derivative of the top and the derivative of the bottom, you can replug this in, and that can be your answer. So it says you're allowed to take the derivatives as long as you get one of the indeterminate, I didn't write this over here, as long as you get one of the indeterminate forms. Does that make sense? So let's go try it with the 2 we just did. I'll apply L'Hopital's rule to this blue one and to that other one. So I'm going to draw a bar here. Oh, it says with L'Hopital's right here. This one says because I got 0 over 0, I can just go ahead and take the derivative of the top. What's the derivative of the top of this function? 1. So I can do a 1. What's the derivative of the bottom? 2x. When I replug, magic happens, and I get 1/4. The exact same answer I got with factor cancel replug. So which one's better for the blue? I kind of like L'Hopital because I don't have to bother factoring, so I kind of like that. It's easy derivative. So for one like this, I prefer L'Hopital, I think, but you do you. Watch me do I'm going to have to erase this. Watch me L'Hopital this guy, and you'll see why. If it's multiple choice, I know the answer to this is -5/3, so why do anything? But I will L'Hopital it for you. Let's split the paper. I've got kind of a mess going here. I'm going to head towards infinity, but I'll take the derivatives. So I'd have a -4 minus 10x. And then on the bottom, I'd have a 6x minus 1. Right now, both of those are still, the top, by the way, is going to negative infinity. The bottom was going to infinity. I want somebody to explain. Mr. Gill, can you tell me how I know the top of this fraction is going to negative infinity? Yeah, it's kind of like end behavior of that top. That's an upside down parabola. And as I go to infinity, it's going down, right? This guy right here I know is going to infinity because this is in control and there's a positive. It's end behavior from, I don't even know, when do you learn end behavior? Whenever you learn end behavior, that's what it is. All right, this is still having that same issue. The top's going to head down to negative infinity. It's actually a line with a negative slope. It's going down. The bottom is a line with a positive slope. So I still have that indeterminate form. So guess what I do? I take a derivative again. You can L'Hopital things, as many times as you need to. This one I wouldn't do this way, but I just want you to see it. The derivative of the top would be the -10, and on the bottom is 6. What does -10/6 reduce to? The -5/3 that Golden told me it was just by looking at it. So I'm going to stop and tell you when you use L'Hopital's rule. When you get indeterminate forms, and it's either the easiest thing or the only thing you can do. How's that sound? So what I'm going to do for this first example is really make sure you understand how these are graded. I'm going to split the screen right here. We're going to show it 2 very different ways because it matters whether it's multiple choice or free response. So on the left, I'll pretend that this was multiple. Last year, by the way, it ended up on their free response. It was worth 3 points, and I'll tell you how. We brought it up. I might still have it on my computer, but I'll probably just tell you. So first thing I do, if this is multiple choice AP exam, I go, LaRude said you got to plug the constant in. And then you go, okay, I've got a 0 on the top. I've got a 0 on the bottom. Correct? So I'm going to L'Hopital. L'Hopital says take the derivative, right? The 1 will go to 0. The bottom's derivative is 2x minus 1. Correct? Then what do I do with L'Hopital's rule? Plug the 0 back in. Sine of 0 is 0. 2 times 0 minus 1 is negative 1. That's no longer an indeterminate form, so it's my answer. What's my answer? 0. This would earn all the points on a multiple choice question because I would circle 0 and nobody would have any clue. And I'm fast and I'm accurate. Agreed? If it's an FRQ, you would get only 1 of 3. So I have to show you how you have to write it. And then on homework, I have you write 4 of them. The rest, you can be sloppy, but and I did this last year, and I was really glad I did, because the very last FRQ, Part D, guess what they had? They had L'Hopital, and it was graded exactly as I said. So first of all, if it's an FRQ, you do not write 0 over 0. I'll tell you why they've decided to be really picky. I'll tell you why right now. Suppose you're doing the limit, blah, 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 of 2 things, this over this, and you got 0 over 0. So then a lot of kids last year wrote this. I was a reader actually for this one. They wrote, that means I'm launching into L'Hopital's rule, and then they did their derivative replugged, and maybe got a 4. Why do you think College Board has said enough of that? Yeah, they had all these kids saying 0 over 0 was a 4, or infinity over infinity is 2, and it's super not correct, right? So they said you are not allowed to write it like that. You have to do it this way. So let's label this FRQ. Again, if it's not an FRQ, the sloppiness doesn't detract from your accuracy, so I'd be sloppy. Notice I even dropped my limits, right? It's super bad, but my answer is correct and it's accurate. If it's an FRQ, you have to take the top and you have to demonstrate that you understand that the top is going to 0. You have to write that down. Then you have to go demonstrate that you know that the bottom is going to 0, and you have to write that down. Writing 0 over 0 won't cut it. Last year, actually, this did, but I was told that's out too. Because last year, some kids kind of did the middle ground. They didn't write equals 0 over 0. They put these arrows, and they were like, yeah, we'll accept it for now. But I think that'll be it. You have to do this. Then you have to tell me, so therefore, you don't have to put the therefore symbol, but I always do. You have to say that you know what rule you're allowed to launch into. Because it's 0 over 0, you have to say by L'Hopital's rule. It looks like La Hospital. The old-fashioned spelling drops the S and puts like a little, what are they, is that called an umlaut? No, an umlaut's a dot. Whatever that thing's called. What? Yes, I think it is. That sounds right. Yeah, some spellings, like the more old-fashioned spelling has like a little, she says it's a circumflex. But just think La Hospital. That's why they have an ambulance on their t-shirt back there. It's for L'Hopital's rule. All right, so by L'Hopital's rule, I'll take the limit as x approaches 0. You have to show a ratio of the derivatives. You can't assume I know you know what you're doing. So you can't just say, therefore, it's 0. I have to see you taking a derivative of the top and a derivative of the bottom. Now you can tell me, what is it, 0 over negative 1? Do you think 0 over negative 1 would be okay, or do I need 0? 0 over negative 1 is equal on my calculator to 0, so you could actually leave that, but for crying out loud, put a 0. Look at how different these look. Do you see how different they look? This is how I would do it if it's what? Yes, this is how you have to do it if it's an FRQ. Also, if there's going to be more than one iteration of L'Hopital's rule, it probably wouldn't be on an FRQ. They just want to know you know how to do it, you know when to do it, and you know how to write it properly. So I would actually use common sense for the next one. All right, and we're going to talk about common sense. Think about how things grow. What do you think's growing faster on that one on the right? The top or the bottom? The top. Yes, it's got an exponential growth function in it. The top will take over. So my common sense tells me that that guy is going to what? Infinity. And if you're 100% sure and it's multiple choice, if infinity is not there, you circle D and E. But suppose Harry's like, I see this going to infinity and this going to infinity, so I'm going to follow Laroude's rule, launch into L'Hopital. You don't do that. Watch me do it though so you can see it. E to the x's derivative stays put, then I get 3x squared. Oh crap, they're still both going to infinity. The top becomes e to the x, the bottom becomes 6x. Oh crap, they're still going to infinity. So the third iteration, boom. The fourth iteration, boom. Now I know for sure, right? That as I approach infinity, what's this going to? Infinity. Yeah, the top didn't even hardly budge and the bottom basically went, right? So it's going to infinity either way. So let's go to the next page and practice. This is actually off a past AP test. So I would do this because it's multiple choice. We'll do it fast. We're going to drop all proper notation, but we'll be super accurate. So here's the methodology for you. You go plug the pi in. You kind of know you're going to get 0 over 0, but you still need to convince yourself just in case. Cosine pi, -1. Sine 2 pi is 0. So my top is giving me a 0. Bottom also 0. Agreed? It's multiple choice, so I've just got chicken scratch down. What will I do next, Alexis? Since I now have that indeterminate form of 0 over 0, what will I do? I have to. There's no other way. I can't factor, cancel, conjugate. Nothing works. So that's where I know for sure I'm going to take a derivative on the top. So I've got a negative sine x plus, what's the derivative of sine 2x? 2 cosine. And they anticipate that kids will know L'Hopital's rule and choke on the chain rule. So this is actually the answer if you forget the 2. You'll see it fall out. All right, so let's keep on going. On the bottom, my derivative is 2x. What's the derivative of pi squared? Thank you. What do I fear that you're going to say? 2 pi. Yes, it's not. It's a constant. So then I replug. Notice I drop my limits. I'll show you the scoring rubric in just a second for how they score an FRQ if you do what we're doing right now. All right. Again, what's sine of pi? 0. What's cosine 2 pi? 1. So up here I have 2 times 1. I have a 2 on the top, and on the bottom I have a 2 pi. Had I not done chain rule, I would have had 1 over 2 pi. Do you see it? So they anticipate that distractor. Here's my correct answer. I want you, though, to guess at, so I'm super into the workings of the AP system because I'm a reader, so I keep myself updated a lot, but I'm sure there's a lot of teachers out there who probably still don't know L'Hopital's gone from being BC to being AB. Right? And what do you think those students choose? They do. They get the 0 over the 0 and they go done. That was easy, right? What are you guys going to do when you get 0 over 0? Keep going, right? And mostly L'Hopital. So let's go take a look at the next one. If you really get it, you know the answer immediately. If this was on an FRQ, it would be worth only 1 point because they know you should know this one immediately. It's actually a higher level of thought to not have to do any work. Wouldn't you agree? Like if you can really think underneath it, the answer is 100%. What is it? 0. Okay, now you could picture L'Hopitaling it. So suppose Eli's like, I'm not convinced it's 0. Just start in your head. What is the top eventually going to derivative itself to? Yes, it's going to go 3x squared, 6x, 6, 0. What's going to happen to the bottom? boom. Yeah, exactly. It's going to keep expanding and expanding and get super large. So as we go to infinity, I mean, when the BC, this is your first time looking at something like this, but nobody in BC would do anything but go like that. We've had so many comparisons of growth lately in there that they'd be like, oh, yeah, the bottom's going crazy. Guess who their biggest growth function is? It's a good question. So you guys deal with polynomials, lines, yeah? X to the x is the king of growth. We don't get that one a whole lot in BC, but x to the x is king. It kills everything. Like 10 to the 10th is 10 times 10 times 10 times 10 times. It's huge. Agreed? Its counterpart that's really close is x factorial. These aren't in AB, but these are in BC. For them, I tell them factorial is king because we don't see x to the x much. It popped up though once last week, but usually it's factorial on down. Factorial kills everybody. Can you give me a really slow growing function like I said factorial's king. Who's the peasant? Super slow growing. Almost as slow as could be. Think of a function. Think of a parent function that grows so slow. Something that looks like square root that even grows slower. Natural log of x is our WIMP. Actually, there's only one function that grows slower, and that's a constant. So, because it doesn't grow, so a constant gets beat out by anything, which makes sense with L'Hopital's rule, because what's the derivative of a constant? I'm right to 0 right away. So constants get annihilated, right? What's the derivative of natural log? 1 over x. Think as x grows. What does that thing go to very quickly? 0. Yeah, so you're actually thinking at a BC level right now, which you don't need to, but let's go. We're almost done. So let's go take a look at this guy, right? Do you think I would use L'Hopital? Now I want you to know when to use it, not how to use it. If this popped itself up on the AP test, is this L'Hopital worthy? No. I could use it, but who wants to take the derivative of the numerator of that? I do not. I'm going to use my old knowledge of the highest power controls the growth of the function. So we'll take that off. Really, what's on the top? 3 actually times the absolute value of x squared, but because everything's positive here, I don't really need to concern myself with absolute values, but yes. So what's the answer to this with no work? 3. So I'm trying to get like 4 things going here. Do you know when to use L'Hopital's rule? When? Go ahead and tell me then. Yes, and you have to have a limit that goes to one of those, 0 over 0, or otherwise you can't use it, right? Do you know when you shouldn't use it? If you don't get an indeterminate form, or if you already know a way like this one, where why would I take derivatives? I get it. All right, so let's go take a look at this guy. We'll pretend this one is multiple choice. It looks very confusing because it's got several skills layered in it. So I first do what you always do. You plug the 1 in. What is the integral from 1 to 1 of anything? And do we understand why it's 0? Yes, exactly. There's no width of the rectangle, so it's got 0 area. It's going from 1 to 1. There's nothing to integrate. So that's a 0 on the top. Don't do this for FRQs, but it's multiple choice, so I'm like, whatever, right? And I go to 0 on the bottom. This is L'Hopital worthy. We do not go circle this. It may end up being our answer, but it's not our answer yet. Agreed? So then what do? I take a derivative, and then I have to dig back into the depths of chapter, I don't know, I think 5, so not into the depths, is pretty recently. No, 3 maybe? I don't even remember my chapters. What's the derivative of the integral? Dump and derive. Yep, and somebody said e to the x squared. Exactly. They undo each other. So I just get e to the, and there will just be a variable change. And when I do the derivative of x, I get 1. But if this was a 3x, remember 3x goes in, you square, blah, blah, blah. All right, so that's the derivative of the top. Here's the bottom. Drop my limit, which is deadly, correct? But I'm multiple choice. Now the answer falls into my lap, and it's probably not one a kid who doesn't know what they're doing would ever guess. Kids who don't know what they're doing like E, they like A, and they like B. They do, because 0 over 0 being non-existent makes sense. Getting zeros kind of makes sense, and maybe it's 1. Our actual answer is probably the least likely one a kid who doesn't know what they're doing would guess at. Don't you think, Harry? Like, Who would guess that? Right? All right. So this next one, you might say, I'm going to use that who grows faster. I'd say I'd be careful with that because these, even though there's an e to the 3x there, which grows really fast, right? It's in natural log, and natural log is very slow. And lines are very slow. So this one I would follow procedure, right? If you pretend you're going to infinity, this will go to infinity. The question is, how fast does it go, and will it override the bottom or get taken over by the bottom, or will they sort of tie and we'll get an answer? Let's go try it. This is L'Hopital worthy. Why? Why? It's in my indeterminate form, and I can't do it any other way. So now they're layering the skill of, this is why we couldn't do this in chapter 1. We hadn't, until chapter 5, we didn't know what the derivative of the natural log of u was. What is it? U prime over u, or 1 over u du. So let's go do that. U prime would be e to the 3x times 3 plus 1. There's u prime over u. That's the derivative of the numerator. What's the derivative of the denominator? 1. This is my new function. Now, when it's multiple choice and you're 100% sure what the answer is, circle it. If you're 98% or less sure, keep on going. Who's 100% sure what the answer is? What do you think it is? It is 3. It is C. But maybe you're like, my gut says 3, but I'm not sure. Here's what you do. Do it until you're convinced, because we don't have anything that says for sure. These are still going to infinity. Let's L'Hopital it again. I get e to the 3x times 3, but there was already a 3. The 1 would go to 0. Just watch. You don't have to write this down. The bottom would be e to the 3x times 3 plus 1. They're both still going to infinity, and I'm not quite sure. So guess what I'll do? L'Hopital it again. I'll get e to the 3x times 3 again. Here's the top. The bottom, I'll get e to the 3x times 3 again. The 1 is now gone. Now I'm 100% sure I've got cancellation. And what's my answer? 3. But my gut was 3, and I have a pretty safe gut. But I would go ahead and run that through until you're convinced. I want you guys to go do this one the way you would have to do it to get full credit on the AP test, which means don't shave off any corners. Write it just in case. And I'm so glad I did this, because last year, part D of number 6 had them do a limit. It ended up being 0 over 0, and they had to know how to write it correctly. So while you're doing that, I'm going to go find the scoring from last year. I think I still have it loaded. 2018. Nope, that was BC. If you can put your pencil down when you think you've written enough to get the full points for something like that, we'll see. Oh, his last one in number 5. I thought it was their number 6, but whatever. Number 6 was the Speedo slope field. Put your pencil down when you think you have enough to earn, let's say, 3 points. Although last year it was 3 points because there was a continuity issue as well, but we'll just pretend it's 3. I'll pass out the homework. Pencils down when you think you've written enough to earn. I feel like I'm short on worksheets. Yikes. Oh, did you guys already grab these? No wonder I'm running short. What'd you say? What's your t-shirt idea? I don't know. I tried to have this one fly a couple years ago. Calculus is the integral of e to the xy. Sexy. No? All right, so let's take a look at the scoring from last year's. You can't see the original question. My point is to show you the scoring rubric. They had to do a limit as x approached pi halves of f of x over g of x, and I don't even remember what they were. But they had to show that the top was going to 0, that the bottom was going to 0, and then by L'Hopital's rule, they're showing a ratio of the derivatives. Do you see that? For the scoring, look at what it says. 1 out of 3 if no limit notation attached to a ratio of derivatives. So if you dropped your limit and you're like, did all the math in your head, what's the most points you can get, even if your answer's right? 1. I'll tell you, a lot of kids with this applies L'Hopital's rule also. There are 2 criteria attached to it. You had to show them going separately. Kids who wrote 0 over 0 did not get that credit. Just so you know. You also had to state that you were launching in to L'Hopital's rule. To get this 1 point, you had to do quite a bit of work. All right, so let's go see how you did on, oh no, where did it go? I'm just going to put it on this sheet of paper if you don't mind, because I can't find my original. What's going on? Do you want to do logarithms? No. All right. So if you guys could, oh, it was just on there. Oh, well, I'm going to steal yours, Ash. So let's go see if you earned 3 points on that one. It was the limit. X approached 3. Oh. My smartboard's saying, come on, it is almost spring break. Let the poor kid, oh, there we go. Let the poor kids be done. I'm so close to letting you be done. So here is the original. Ashley, since I have your paper, what do I need to do to get some points? Go ahead and get me started for what I need to show if this is an FRQ. Yes, you need to do the top and bottom separately. You going like this was a definite no. Kids who went like this, I told you last year it flew, but they said that's no guarantee that it'll happen again. All right, so we show that the top, the limit, as x approaches 3, you should rewrite the top, but I'm too lazy, went to 0. Limit, x approaches 3 of 9 minus x squared equals 0. How many of you wrote that? Good. You only do this on an FRQ. Then what else did I say you have to do? Yes, you have to state the name of the rule you're applying. So I usually write therefore by. Last year, we were allowed to give credit for kids who wrote that for L'Hopital's rule. But I wouldn't assume that they accept those things. I would just take 2 seconds of your zillion minutes, L'Hopital's rule. So therefore, by L'Hopital's rule, you didn't have to write the word rule. Some kids just wrote L'Hopital's. I saw a couple of these, L'Hops. I'm like, yeah, I know what you're talking about. I do. So by L'Hopital's rule, you'll say the limit as x approaches 3 of. Now what you have to show a ratio of derivatives. So you need to tell me as a reader that you know how to take the derivative of the top and you're not just guessing. Does that make sense? So what is the derivative of the numerator of this fraction? Sine pi 2x. Yeah, exactly. It's just dump and derive. So I do sine of pi halves x. What's the derivative of the bottom? Was it a negative down there? Okay, thank you. I lost this problem. So a negative 2x. Now I replug, and you will only have one iteration on an FRQ. They're not going to waste your time or our time reading it by you running through it over and over again. So what 100% sure is sine of 3 pi halves? Negative 1. And on the bottom, I would get a negative 6. So you could leave that or write 1/6. How many of you wrote it exactly like that? Most of you? Awesome. We're done. So for your worksheet, here's what I want you to do. You're going to circle these 4, and they're the 4 you have to write them as if they're an FRQ. I can't give you a bunch of FRQs on this. Do you know why? Yeah, it wasn't introduced to Calc 1 until technically 2017, but it wasn't on the exam until last year. So here you go. All right, I want you to show work on number 5. The other ones you can be sloppy, but give me some good notation for number 5. Flip the page. The second one from the top, the limit of e to the x minus cosine x1. Just put a little star by it maybe so you know when you hit those, you're going to slow your roll and be a good girl or boy. Boys are never good though, they smell funny. And then on the bottom, up to for the sine x cosine x over x, that's another one to star. And then on the last page, letter C, put a star by it. Other than that, you can kind of do you. Here's a question that came up this morning that we'll take care of. It was with number 4. So I had a group of boys kind of having different answers, and I heard them kind of squabbling about it. So we'll go look at number 4. They plugged in a 1, and all 3 of them got 0 over 0. They all launched into L'Hopital's rule. So let's go do number 4. We get to be sloppy because it's not one we circled. So you can go ahead, just write the derivative down. Go ahead and write the derivative down. And you go, dang. It's still what? 0 over 0 on my replug. Remember, I'm taking the limit as x approaches 1 of this. I'm still at my indeterminate form. Shoot, now what? Do it again, and they did. That wasn't their issue. I'll show you where it came and see if you guys can answer my question. They did it again. It's no longer 0 over 0, correct? So now when I plug in a 1, because remember I'm going to 1, I get a 2 over 0. Here's was the debate in my second hour class. Some of them did L'Hopital's again and said 6 over 6 is 1, where others stopped here and said the answer was infinity. So who's right, the 1 and the infinity? Because they're very different. Why? Exactly. The infinity, this once I hit here was no longer going to meet any more criteria because it's not one of the 2 indeterminate forms. That is done. Okay, now here's another question. Suppose Mr. Gill had taken the original, or even right here said, I'm bailing, I'm going to factor. Let's see if you really get what you're doing. So he's like, I'm bailing on L'Hopital. He's stupid, right? And he says, I'm just going to factor now. What do you think is one of the factors? And where do you think it was? And it didn't cancel. That's a really good question. Yes, x minus 1 on the bottom and super fast. How do you know that? Right, well, if my limit, remember these are y values, is unbound, it means I must have hit a what? Asymptote. Vertical asymptotes occur when the denominator equals 0, correct? And doesn't cancel with the numerator. So I'm 100% sure if I challenged you with factoring it, you're going to find an x minus 1 only on the bottom, right? So we're done. Go ahead, have at it. I should have taken my headset off long ago. Notes were done. Oh well, they get long notes. I am done.